the first video lesson of the year. So you'll see our do now is to construct an equilateral triangle, ABC, given the segments of A and B. We've done this already in class, so pause the video and go ahead and try to do this construction. Welcome back. So in case you forgot to make our construction, I'm going to start with my compass at A. So on your compass, it should be the clear piece. And I'm going to stretch out so it's got a length of AB inside the compass. We're going to make an arc up and over. And without changing the length of our compass at all, we're going to go point B this time. And we're going to make the arc from here down. That intersection point, that's our point C. And now we'll be able to make the equilateral triangle, because I will take the straight edge and just connect A to C as well as C to B. The thing we should know about triangles that we haven't talked too much about yet is they have 3 angles. In this case, because it's an equilateral triangle, all 3 of these angles are the same. And triangles add up to 180 degrees, which means that each of those particular angles is 60 degrees. So in here, fill in that we have 60 degrees written for the question below. We want that because 60 degrees is an important angle within geometry. We're going to see that as we try to rotate our images today. So we talked about rotation in class. It's a type of transformation that preserves length and angle measure. We're going to start by looking at a segment A prime B prime, which is the image of AB after the rotation of 60 degrees around the point A. So we know that 60 degrees is closely related to the equilateral triangle. We're going to use that today to help be able to make this construction happen. And also, I want to highlight that we're going to rotate this around point A. So that means point A will not move. That's going to be our center of rotation here. So when I go back and take my compass, I'm going to go grab it that I brought it to this page. My compass is going to help us. So let's bring that to the bottom. Now I should start with my clear piece A. And we're going to stretch out so that we have the length of B in our segment again. Now what we should remember is, like what we talked about today, rotations primarily go counterclockwise. So I'm going to make an arc counterclockwise in this case here. Now from B, I can make this point. And I've gotten this intersection. Now that's exactly how much we've moved. A is staying in the same spot, but this new intersection, that's B prime. And we wanted it 60 degrees. I'm just going to use a dashed line just so we can tell the difference between the two. And you don't have to ever dash your line, but now this new line has been rotated 60 degrees counterclockwise from point A. Now, on the next page, we can go and do it again, but this time it's from point O. Now, this point is not on our line segment, so that means that O won't move, but A and B should. So when I go to do this construction now, it's important to always have the center piece start. So what I mean by that is your clear piece should always start at the center. And now I'm going to stretch out to A. Again, we want to make sure we're going counterclockwise. I'm going to go an arc here. Since I want to rotate it 60 degrees, remember, same as the equilateral triangle. And here we get the new point A prime. So this is where our point A prime will lie. We're going to do the same thing again, but now we're going to do it for point B because we have to rotate both points this time around. So again, always starting at the center. We're going to stretch out to B instead of A this time. And we're making a counterclockwise arc, so we're going to the left. About as much as we would need for an equilateral triangle. I don't have to do the whole equilateral triangle. All I have to do is get that intersection point. So now that I have an intersection, I'm going to label that B prime. And same as before, I'm going to make a dashed line. You can make it a solid line. I'm just doing this so we know the difference between our two lines here. So this is rotated 60 degrees. Both points have shifted. Okay. Now, for both line segments, they would be segments. Remember, rotation motions always preserve length and angle measure. So as a segment, those lengths have to be intact. But if we're rotating a ray or a line, it doesn't have to be any kind of particular length because we know we'd have arrows on it and it would technically go on forever. But it does preserve our angle measures that are created as well. Now, in exercise 3, we're going to try to go a little more. We're going to rotate 120 degrees. But if we think about that, 120 degrees is just the same as rotating it 60 degrees twice. So we're going to do the same kind of construction. We're going to start at O because that's the center. We always start with our clear piece at the center. We're going to stretch to A. We're going counterclockwise. I'm going to make a little bit bigger of an arc this time. And you don't have to be this big. I want to have enough room. Then I move over to A. And what I should notice here is that I get this first arc. Now that would be the point I wanted a 60-degree rotation. But remember, we want 120 degrees. So now, from there, I pick up and I put my clear piece at that intersection. And I'm going to get the new intersection. That is going to be A prime because it was 60 here. And then another 60 to make 120. So pause the video, same thing for B. Hopefully you got a arc that was falling about here. Remember, we went counterclockwise. Then we went to B and made our point. And then we got B prime. And I made that dashed line connected the two. Now on your page with exercise 4 here, you'll see that we are talking about a triangle MNP, which is the image of triangle JKL after a 120 degree counterclockwise rotation about point Q. If you measure the angle L, it's going to be 47 degrees. And we measure the angle N, it's going to be 56 degrees. Determine the measure of angle M and explain how you arrived at your answer. So there's two big things that we need to kick out of today's lesson and yesterday's a little bit as well. One is that we know now that triangles to 180 degrees. What we also know is that rotations preserve angle measure. So let's use that here. When I look at this, I'm setting up this screen because remember how I set this up. The order of the points matters. So how they state these points to me is something we need to make sure we carry on throughout the rest of the year. MNP and JKL. You'll notice over here, M and J line up, N and K line up, and P and L. So L is 47 degrees, which also means P is 40 degrees. N is 57, so K is 57 degrees. So we have 2 out of the 3 angles of these triangles. To find the missing angle, we're going to add the 2 together to get 104, subtract from 180, and we get 76 degrees. So angle M is equal to 76. Now our reasoning behind that, though, is those 2 things we just mentioned. Angles add to 180 degrees when we add up all the angles, and rotations preserve angle measure. That's for the explain part of it. Because remember, we always use a set of words when we're trying to explain what's going on here. Now on the next page, we're going to rotate a line AB into a new line CD. But this statement here is saying that E is your center of rotation. We're going to rotate 180 degrees, so A becomes C. And we're going to use E as the center again of 180 degrees, with B moving on to D. Now, before we did the 120 by doing 2 marks. If you notice, 180 is just the same thing as doing it 3 times. So you could do it that way. But there is another way of doing this construction that you might find easier, and it only works for the 180-degree rotation. Is I'm always going to start with my compass clear piece at the center. So we've been doing that this whole time. So I'm going to make sure that clear piece for us is at E. And we're going to start with A. And I'm going to stretch out so that that's in my compass. Locked and tight. Now remember, I'm going counterclockwise, but it really doesn't matter which direction I go in for 180, because if we think about it, 180 degrees is exactly half of a circle. So the rotation could go either way. But we want to make a big arc, because remember, we're going a bigger distance. So I want to make sure I go more than halfway. Because we know that 180 degrees also represents a straight line, I'm going to cheat a little bit. And I'm going to make a line here. I'm going to just use a different color line so that way we can see it nicely. And I'm going to draw a line from A through E until it touches this intersection. That point along this arc is going to be 180 degrees. It's going to be across here. Remember, we said we were going to call A is now going to be C. So I'm going to use that here. And that point right there is our point C. We still need to do the same thing again now from B. So I'm going to make a different color here. I'm going to always start my clear piece at the center of rotation, so that's E. We want to stretch it so it's to B. Going to go a little bigger. And I'm going to go 180 degrees. If I went a full cycle like I just did, that works too. I'm going to switch the colors so we can see which ones go together here. Now from B to E to when it touches the red, because remember, that was the intersection I care about right now. That new point, B, turns to D. And the very last thing I do is I make sure to draw the line. So I'm going to draw the line that touches both of these points. I'm going to extend this a little further and make sure that I have an arrow on both sides, like we just said. If it starts with arrows, it should end with arrows. It should always be the same as whatever it started as. Now we have a rotation of 180 degrees. And you might notice that these two lines will never intersect. Remember, that's known as a parallel line. So if I go back here, we'll see our geometric fact down at the bottom. So the geometric fact is a line rotated 180 degrees around a point that's not on the line already will always result in another parallel line. And we're going to see that down underneath here. So we have to understand some important properties of parallel lines. So this is our symbol for parallel when you have two lines next to each other like this that never touch. So underneath, we're going to look at AB, which is parallel to CD. They're crossed by this third line, M, which is called the transversal. This transversal forms alternate interior angle pairs that are marked here. So we have the angle ABE and DCE. Those two are alternate interior angles. Think interior, they're inside, and they're alternate sides of the transversal. If I were to rotate EC around 180 degrees, that's got to land right on BE, because we also said that point E was the midpoint. Now, over here, there's only one place, and the big idea that I wanted you to get out of this is that these parallel lines are always going to form congruent alternate interior angles. So we can fill this in on our notes. We just want to know that if we rotate this, these two angles have to be congruent together because of this midpoint and because of that passing through a given point we talked about last week. Thanks for watching.